Hello everyone.
Good afternoon, ladies and gentlemen.
Okay. Right, carry on.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is local and remote cache usage in Java enterprise applications. Our guest speaker today is Tushar Kapila, Architect Excellent. Tushar has 13 years experience spanning Java and PHP implementations on Windows and Linux platforms. He has worked on web projects ranging from 2 months to 2 years. Tushar has led teams of developers and QA to improve performance and security, making sense of requirements that are not met by standard out-of-the-box solutions. He has built frameworks for Excel report generation, data extraction and transformation, testing and automation. So without further delay, I introduce you all to our guest speaker. Over to you, Tushar.
Hello. Can you see my screen? Okay, just sharing my screen. Hi, so we're going to speak today about caching in Java applications. And in the simplest form, a cache can be a hash map in your own application where you keep some information, and just like any other map, it has a key and a value. The key can be a string of the object, and the value can be a string or an integer, or it could be a complex object, or it could be some blob data like an image as well. So you can frame questions on the chat, and we will look at them towards the end of this talk, and we will have one sample application to show you as well. So the first question is that to partly answer that hash, and the simplest answer is a hash map can be used as a cache. Though it's not the best implementation, we would at least go for a LRU hash map where there's some automation so that your RAM of your JVM is not used up by the cache in case you have a lot of items in it. So some of the examples of the things which we can cache are things which are seen or used by many of your users, like example images, CSS, JavaScript resources, audio. And then applications you have calculated values, like earlier I was working on a 3DS project where we used HSM to encrypt data. So that is an expensive operation. First of all, it is over the network, and then there are complex cryptography required to be carried out. So where we used to cache for a few minutes or a few hours, so that if in case the same cardholder or a similar data like the date of birth of two people could be the same, if the same kind of data comes back to the application, the encrypted value is already available to the application. And of course, depending on the security of the encrypted data, you would be in memory and you would not put it out to any disk and things like that. Whereas some other things like a Java object which is in memory and it could be in the data, you might want to cache it in your RAM and in your database because it is a persistent entity object. So the basic guidelines are that anything that takes time to create or is used by many people are good things to cache for us. Okay. So there are many cache implementations. One of the first ones which I used was called Whirly Cache, which is this simple Java code which you can drop into any application. And it's one of the things which is now replaced by the LRU cache in the Java, but it was one of the earlier ones. It was made, I think, about 10, 11 years back. And Whirly Cache has an XML API-based configuration where you can how big the cache should be, how often the tuning thread. A tuning thread in a cache is runs every minute or every 2-3 minutes and cleans up the cache, which means that if you have said that an object should only live in the cache for 10 minutes, or if your size of the total cache should be so many MB, then it will try to clean itself up. Though the MB is not exact, it's followed to some extent. Then we've all probably come across caches or use them indirectly. For example, the Apache web server, which was still recently one of the most used web servers, has a mod cache so that images and CSS will not be from the disk every time. Instead, it's kept in memory back. And one of the negative sides of this from a dev or from a deployment team's point of view is that you need to be able to tell the cache that, hey, this item is now stale because there's a new item, and so there are different functions in caches to do that, or the simplest way is to restart the cache itself, or the application which has a cache like the Apache web server, so that it gets reset. Okay. Squid is a cache which is used by Wikipedia. So Wikipedia, I think, is one of the top 4 web services today, and use to cache their pages so that you don't have to hit the file system or the actual PHP code to see a lot of content. And this is the same story with Facebook, Google, and all the other top websites that you would use today. So why should you use it? For scale or usability. So what I mean by scale is that so that you can have even more users using your application, and without having to add databases or app servers, you can add quite a simple, and there are many free implementations of cache in front of your web server so that you can make use of it. And generally, when you have problems of scalability, programmers want to knock off a few features, or ops people want to invest a lot of money on improving bandwidth, etc. The systems team just want bigger and bigger servers. But when a lot of these, the simple and only practical solution in the long run is to cache. And like I said, that all the big websites use it, and that's enough that it's a working concept which is being adopted by medium and large enterprises. And the second point was on usability. So for usability, even if you have a small little website which is just used by your intranet or your family, even the usability of your website will greatly be enhanced if you use caches, because instead of the same thing, instead of like an image being loaded and then sent off, it is sent from the RAM of the website. So the basic reasons are that database access is expensive, and besides being expensive, if you use your database too much, then you might have a scenario where the database itself crashes. So things like page counter and things like that, you might see that, oh, it's just like one piece of data which is being read, that how many times your particular blog entry or etc. has been read. So even something like that can crash a database, because if there are thousands of requests spanning different database entries, it can cripple even the best of databases. So now coming to the types of cache, we have 2 main types. One is a cache which is on the same JVM, and a good example of that is Whirly Cache or the LRU hashtag implementation, which Java gives out of the box now, and at least if you're using Java 6 or above. I'm not sure when it came out, maybe Java 5. And then you have out of this caches, which means that you're basically extending the total memory available to your program. So there, even if you're using 64-bit operating system, there is an upper limit on the amount of RAM that your full system has, or that one process can be allocated. And using an out-of-process JVM beats that. And the other great advantage of using an out-of-process or remote cache is that your application can have 4 or 5 nodes, and using the cache, they can share data among themselves. So one way to do this is to, for shared sessions, but I mean, I have not used shared sessions for the simple reason that, hello? For the simple reason that it leads to a lot of synchronization and issues with the JVMs. But on the other hand, if your application is built, the architecture is such that any of the boxes can serve a request, and then you can have a mechanism by which you can just share data in a pull fashion instead of a push fashion. It means that the synchronization is passive, and the particular application server instance which gets the request, it can pull on some other ID from the remote cache. So this is your typical, nowadays setup, that you have a browser, and you can have the browser can have its own cache, or the the whoever is the internet provider of that user, he can have their cache, and then that is not in our control. And then in this below blue box, we have what is in our control. You have firewalls, and you might have a DMZ, which is a demilitarized zone for high security applications. You might have reverse proxies and web servers. Reverse proxy is an implementation of a cache where you can have a specialized software called a reverse proxy, which can cache items for you, depending on what the MIME type or the URL. Have its own functions to clear the whole cache or clear part of the cache when something goes stale. And then is used again more in high security applications like payment gateways, etc., where the app server is completely separated from the web server part, and the app server would be actually accessing the file system and serving the images, CSS, etc. Be the one be calculating encrypted values and things like that, and behind it, it would have a database for long-term persistence and other functionality which the database is the best to provide, like IDs, etc. So again, where the cache can fall in here, or 3 places. One cache can be in the reverse proxy web server layer. Then another set of proxies can be used on the app server level, such as in JVM cache or a remote cache in both cases. And some databases have their own caching mechanisms like MySQL, where you can cache queries and the such. So you might say that the databases are fine-tuned, and how slow is disk reading and things like that. So I have some numbers for you, and this is them. That on a regular computer, these are some numbers which I pulled out from a stack trace website, which shows us just how fast cache can be. So the cache part is, if it's a local cache, it is just the main memory reference or the L2 cache, depending on how it's designed. And if it is a remote, you would have that RAM access plus this network access, how fast your network is. And then you come down here and you can see how exponentially larger the disk reading is. So disk reading is much more slower than and plus the big part is that IO blocks, even if you do it with the new IO in Java, there is an overhead of resources, the number of resources that are available to your box itself, and a subset of that would be available to your JVM. So instead of simply trying to put that to the maximum, it is far, far better to cache it and get all kinds of benefits, from free time for your app server to higher usability for your users. So this data is from server fault. Okay. So now I'm going to jump into a little code and to help you guys, to help you folks to see a cache in action in 10-15 minutes after this talk. So if you go to this and download Quick Cache, which is a kind of a memory implementation in pure Java. So the only thing which you require to run this is Java, and in the download pack it has a sh file and a bat file to run on Windows or Linux, depending on what you have available. And this is the short command you would give on the command prompt to get it running on port number 11212. And I generally, the default we do is 11211 and 11212. Right, so once you do this, you would have your running. And you can test it from another terminal by doing these commands. So basically I'm connecting to that same port, and I could say, get key, I could say set key, and you can just copy this, figure out later what it's doing, but it's basically telling the system to store a key with the name key1 and what the expiry is and how many bytes will be following, because it's a telnet kind of test application. So then you ABCD over here is the actual data which I'm sending to here. So this is the set command, and then I'm saying that I'll be sending the expiry is 3600, and I'll be sending 4 bytes, and these are the actual 4 bytes. And then the server is telling me that it was successfully stored, and then I can get it, and I can again verify that what I sent ABCD is what I got back. Right. This is a test application which I will give you the URL to, where you can go and download it. It's built by me. It's freeware. You can get the source code and jar to run. So it basically, on the command line, you can tell it what the servers are, or through the source code if you want to edit the source code. And you can set different values and give it a TTL. So TTL, the name of the key is here, A key. This is the value over here. And then this is, application has some messages to help you understand. So I've run 2 instances of the same application, and you can see that it will get the remote server. So this is some of the behind this, where the server is running separately, and this is on your application what you would do to build up a cache. So you would have a cache as a static variable or as some kind of object which, if you're using Spring, which has been injected into the other classes which require it, like a singleton, it would be like one instance of the same bean would be used. Unless in some special cases you can have 2-3 caches, like you can have one cache for some Java objects, you can have one cache to store images, you can have another cache for encrypted values. That is the exact setup which we were using in my previous company, where which most people would have used if they've done a CDS transaction in India, because we used to do it from banks like Axis Bank, ICICI Bank, where we used to use remote caches. And we saw great performance boost when we started using it in the year 2010. So it's been running now for like 3 years, and it's been going very well. So now I'm testing the from my code a key, and then I'm saying what this is the key, some key, then this is the expiry time, and this is some object which happens to be a string. And then I'm trying to get the object, and of course I can get it from in another JVM totally, because it's a remote cache, so it can be between different clients who are running on separate JVMs. It could be on separate box or a separate physical location as well. So if you go ahead and download the sample application, I've included some exercises. This talk also will be downloadable, this PPT presentation, and I exported in PDF format. And things which you can do are like, read value from terminal after setting it in the UI, and you can wait a few minutes and see if it's expired or not. So that is one using cache, that you have to have a backup plan. So a cache is highly available, but it is not like a database where the database provides you with a high reliability. So a cache could have gone down. There could be a network problem with the client might decide to drop a few requests because it's being flooded with too many store or too many read requests. And so you have a backup plan, which means that you tell the cache that, hey, go and get me this key, but then if the key is not there, you need to be able to go into your database or to recalculate the value or read the file from the disk again. So it's a performance and scalability boost. It's not the end-all solution. And origin failover is where you hit one server, but even if that server is down, then you might have horizontal scaling on your app server where you can go and hit another server and get the same data which your web server is requiring. And touch and get is a concept where you have stored an object before, and you want to tell the cache that, hey, keep it 5 minutes, but if somebody requests it again after 3 minutes, then keep it for another 5 minutes. So you might not know if this item is going to become popular or not, but as long as it remains popular, you want it to remain in the cache, and once its popularity goes down, then you want the cache to automatically remove it, which is very useful in today's social applications or even in a static website like serving a blog or some other articles. So you might have some article or some thread which is famous for a few days or few months, and then it becomes less famous and other items will come in its place. So you don't want it to lock up your cache, and you don't want to go and manually clear it. So you can have this touch and get and extend the expiry by incremental amounts, and then finally it will get out of the cache when it's not being requested by end users anymore. So now we've seen about where you can use a cache. You can use a cache for images, you can use it for calculated values, you can use it to improve usability, you can use it for scalability, so that instead of hitting the database, you can instead use the cache, because it's much faster to go over the network and RAM than to go to a database and have the database read a physical file. Though that's much more reliable, it's not the fastest. So, but there are ways how you can abuse cache. And when cache, what will happen is that the cache will not perform as well as it could have. It will run out of memory. It will it'll be taking up too much time in garbage collection and in maintenance and trying to figure out what to clean, what to keep, things like that. So if you a large amount of data which is just specific to one user, which no other user requests, but you're still caching it. So what will happen is that unless your application is only composed of 2-3 users, if you have like hundreds of users or 10,000 users and more, then if you cache specific data to each user, then you'll really need a hell of a lot amount of remote caches, which will not be feasible, and your application will again start crawling. And then another way how to abuse a system, a cache system, is that when there is some kind of, I was explaining like a thread or a new post with some very nice image which a lot of people are liking this week, if you give like an expiry of 1 month or 10 months, then again next week when there's some new funny image, some new blog post which is very famous, then it will all start piling up, and again it will be like the first problem, that you'll have too much of data really using, and your cache also will get flooded with too much of content, which is not, and it will not be able to handle it. Sometimes we also, just because we don't have time or we don't know how to implement things exactly, instead of caching on the web layer, we start caching on the app layer. And things like final web pages which are common to, you need to cache on the web layer, whereas something like an encrypted value, you would probably want to cache it in the app layer because it does not make sense and is out of place on the web layer. Of course, if there's some data like an OTP or something which is only going to be used once, then it probably does not have to go into a cache. Though if your whole application depends on serving that OTP and verifying it very fast, then there are instances where, again, just like all requirements, you have to talk with the business, do some calculations behind, what is the quantity of data and what is the latency which you want to, what is the the turnaround time which you want the user to experience, and then decide what to cache or what not to cache. So what might be one person's abuse might be another person's requirement. So that is also something which you need to think about and evaluate if you decide to use caches. So the next thing is that how are you going to measure that, oh, I decided to use caches, but has it made a difference? So one way is that your users hopefully will come back and tell you, wow, your application is working much better. What have you done? Have you added servers? Have you added, some new technology? But it could just be as simple that on the existing servers itself, you just added one more application, which is a remote cache, and your code is using it now in a good way. Because at least in my experience, I've seen that most app servers have a lot of free space for RAM and CPU cycles, and a good cache would not use more than 1 or 2% of the CPU. So you can generally even leverage, make use of your existing servers and just put 1 or 2 more instances of caches running on them, and then suitably edit your code to use them. Of course, in some very big applications, like the 3D system, we used to have caches running on special cache servers, and we had, for some specific requirements, we had some internal in the same JVM caches, small caches of like 100 MB or so, and on the same system for speed, we should have local caches. Local means on the same box caches as well. Because there's no doubt that when you hit the local host, it's much faster than if you hit something else on your same VLAN. So the ways to test is the best way, I would say, is through Selenium or JMeter, unit test cases, things like that. Though you could always do this with a manual clock with cache and without cache. So before you measure it, you need to first plan out how you're going to be using your cache. And you need to decide, like I said, what to cache. Then you need to plan your database file system so that if it's already a running application, you might not need to do this. But if you're doing it afresh, then you definitely should plan it out that when you're going to hit your database, when you're going to hit your file system, when you're going to hit the cache. And like I said earlier, that you always have to have a backup plan, that if something is not there in the cache, you cannot rely on the cache. You have to have a plan B where you will go to get the item which is being requested. And then you need to prepare your code so that the code like Hibernate code or the code of your web server would have some add-on which will allow it to use caches. You would have to prepare that XML files or the conf file so that it uses caches. And then in some places where you're calculating some code like an encrypted value, you would start storing it in the cache and make a few changes and then measure again, then again make a few changes and measure it again. So on this next slide, I have some sample data that this was used using Selenium and JMeter, where we were hitting an application with some 220 requests. So this is after a restart that you can see that it takes a little bit more time while the JVM gets warmed up and all our code gets initialized, and then we see that it's quite high. And the time, which is the red bars, are the time it took to service the requests, which are represented by the blue bars over here. And down here you can see that with cache, the initial time was a few seconds higher for the same 220 requests, but as time goes by, the time to serve keeps coming down, and then it settles down again in one approximate average time. There are always some variations because of network and the system might be doing something else, or there might be something new which has to be cached. So it will be like a normal request. Plus, it has to be entered into the cache so that it is returned from the cache next time. So this is some data around that. So this is the URL where you can get the code which I showed you the screen for. And if we have time, we can even see the sample application working. And I've also given a link of Apache modc because that's one of the web services used quite a bit. So I will show you of running the cache server now. I have a command prompt open. This -vv is for extra plugging, but we don't want to do that generally. I'm going to be starting 2 remote caches now. So the server is now loading. It takes a few seconds. And now it's telling you that it's listening on port 11211. And the second instance is starting on 11212. It started now. So now I'm going to open another command prompt. And I'm going to telnet to test this. Now the telnet test session has started. So I'm just going to test if I can read a particular value. And now I'm going to set it. I've kept these commands ready so I can quickly now it's stored the value. And if I say get, it will return the value. Now we'll move to the application, which is a much better way to do this. So I just have a small little batch file to start it. And you can see on the startup screen how it is connecting to the remote caches, which are command line parameters. And now I can set a new key and give it some value. Give it a TTL, set it. Now I can open up a new one, the same client in a new instance. So we have 2 instances of the same application connected to the same remote caches. And here I set a set. Now I'm going to do a get. And we see that we stored in the earlier instance comes here. Similarly, if we store with some key here and set it, now I'll go and request key B. The secret, of course, is that both your applications should know how to make the keys and what the common keys are. For example, in the application where I was working, we used to store in cache email templates. So like we had many customers and many banks as customers, and each bank had over 40 emails which could be sent to a customer. So instead of reading the email template from the database every time, we should keep it in a cache. And then there was a common format of the key depending on the customer ID and the event ID, what type of email we were sending to the customer. So there would be a particular key. For example, you would have bank, times, and then you would have email 1, and then this would be like dear customer name, and then some some contents which tells the customer what has happened, like you started a new account. And then you could like have a multi-line email, and then you could have URLs, etc., all in this template. And then so it's set into the cache by the first app server which requires this, and then other app servers which need it could just simply get it, and they would get the same, be like a big blob. It could be an image, it could be any data which you have RAM for, you can store it in there. So this is a little test application to get you help you get started. You can get the info from the link which I've provided. So let's go back to the PP station, and this is the link where you can get that code. And I'll be adding some more code after 7-8 days to the same location. So for some sensitive applications, a question can come that, how secure is the cache? That can somebody cache and get data which they're not supposed to see? So the answer to that is that the cache, at least the example which I showed you, is a Java application, and it has as much security as any other Java application running on your network does have. And the main thing is that, for a server, you need to restrict the users who can access it, who can take memory dumps, etc., to keep your application safe. So if they can take a memory dump of your main JBoss or your main application server, then they as well can even compromise your cache. And some caches like Varnish cache even have access control built into it, so that you can provide some information and you can tell the cache what resource is viewable by which user or which type of user. So Varnish is, I've not used it myself, but I've read that it has that capability also. So two parts of security. One part is how secure is the cache itself, and it's as secure as any other Java application in your network. And the second thing is that can a cache do part of your app server's work of holding access control for your users? And the answer is that some caches which are no longer just simple caches, but they even have ACL aware, and one example of that is Varnish. So this is acknowledgments of some of the materials I've got from here. Varnish software is that link I've given. cache was one of the first caches which I used, but then we got implementations which we knew more about, so we started using them, which were mainly built by us, using memcache as a template, as a starting point. The cache, I've mostly explained how it can be used in a web application. I've shown you how it can be used in a desktop application. So this little sample here is a desktop application which is using a cache. So similarly, you can use a cache in an applet as long as you have security provisions for it, or it's going over HTTP, and you can use it in a web start application, depending on it. Some internet applications might make use of caches internally, though most of the place where I've seen them being used is in web servers and in application servers and in server-to-server type of applications. Nothing stopping you using them in standalone applications if that is what the user base would benefit from. So it's time for questions. Do we have any questions?
Thanks for the insightful presentation. Let's quickly take up the questions now. I would request all the attendees to start sending their questions. Hello, Mr. Tushar. Hello.
Yeah.
I've assigned you the questions.
Yes.
Yeah.
Okay. How can we implement distributed cache? So distributed cache is basically a cache which is not running in the same JVM as your application. So the example which I just showed you, is my screen still shared? So if you can see my screen right now, you are looking at a distributed cache. So on my computer, this is the folder where the quick cache, which is an implementation of memcache, which is a very popular implementation in C++. This is where it is running. Now, if your company allows you to put memcache, you can put that. And if you only can put Java applications and you are more safe, if you feel more confident by using a Java application, then you can download this quick cache, which is all pure Java code, and it has some clients also which are freeware in Java. And I've given the link to where you can download this. It's from code.google, so it's open source, and it's been that we have in the company which I was earlier, which is called, which does banking work for ICICI Bank and Axis Bank and a whole lot of other Indian and foreign banks. We've been using this quick cache from the year 2010, and we've had phenomenal success with it from end users to bank managers congratulating us because we improved the performance by for some kind of requests, we improved the performance by about 250%. For some of them, it was like 500% because we had a lot of HSM calls and a lot of images and JavaScript which we started caching. Again, at different places, like I told you that we are using remote cache on the web server part. We're using remote cache on the app server part for some values and for email templates, things like that. So instead of like a disk read taking like 2, 3, or 4 milliseconds, and that too, as for every request, it just becomes in the order of like 100 nanoseconds, and then again multiply that by 10 TPS amount of transactions. And even if you have like 10, 15 users, they will even notice that your whole application is responding much quicker, and the complete page gets rendered much if you are using no caches. And we have less crashes now because the disk needs is less, the app server has less strain. We have divided the work into more than one JVM. So here you can see that for this setup here, we have 4 JVMs. So on, and none of them you know, are taking load. If you look at the task manager, so they're like virtually free. Our CPU 0 and memory is whatever you give the Java process when it starts off will be the maximum memory that it uses, like any good Java application. So you can take advantage of that. Right. I hope I've answered that question. If you have any other follow-up question, I'll be online for a few more minutes. Okay, I'm trying to open this question bank. Sharad Saxena, what can be other options to use in tandem when cache if, for example, cache data is large in size? That's a great question. So I actually have not I have not had the need to do something like that, but what I have read in another website, which is the Varnish website, where in the he describes a way where you can divide up your um, you can divide up your page. Like for example, that you have. I hope you can see my screen. I'm drawing what denotes a page. This page, for example, if there is some content which is very large, like say you have a video file, so the video file is here, and for whatever reasons you cannot cache it, though I would suggest that you do still cache the video as well. So you can keep this content out of the cache, and still you could have like some regular comments over here. You could have comments which are cached. So this is actually in your control, that you are the application developer, and you can decide what is cached and what is not cached by the logic which you build in your application, so that not everything has to come from the cache every time. And then you have the video, which could be on a different server. So depending on the URL and what that server exactly is doing, it could have a different mechanism. Okay. We have another question. Okay, what is the key point we should keep in deciding which implementation of cache to use? Okay, so that's also a great question, but a little bit difficult for me to answer, because the basic thing is that the basic thing which you have to see is how much of time you have. So if you have, I would say if you have enough time, then please do go ahead and try to experiment with at least 3-4 caches. Whereas if you have something in particular which you like need only a freeware cache, then definitely go with something like Quick Cache or Memcache, which is open source and free. Whereas if you have something which, like for example, if you wanted access control also for your caches, then, and if your project has a budget for this, then you could go for something like Varnish. And Cache, I've heard that a lot of people have had a lot of success with it, but when we tried to use it back in 2009, and we had some problems. So that's just my personal opinion, because it's a huge company and they've had a lot of successes. So Cache can do everything else which Memcache can do, and they're also very active in that team in improving it. So there's no real definite answer that this is a checklist and do this, and come with your answer. But it's mainly a question of how much of time you have and how much of budget you have, and if there are any very specific requirements which your project has. Okay. So I'm trying to scroll through the other questions. Do you have any information about OS cache? No, I'm sorry, I've not heard about that. But if you have a more specific question, then I can you can ask it now, and I can try to answer it via this website, or to that link which I gave you. I can upload an answer by this Sunday if you have a more specific question about OS cache. But I don't really understand what the question is. That if you could give something a more specific question, I can upload it here. If you are just looking at the general thing, then no, I've not heard about it, so I can't help you much there. Okay. Just looking through the other questions, what is the difference between server cache and remote cache? Okay, so it's all in language. So a server cache, I mean, and it depends who is asking the question. So if I'm a website user and I'm like going to facebook.com, then for me, if I'm like looking at the comments posted on a particular thread by a friend of mine, probably Facebook is using its own cache to give me that information. All right. And so for me, that is a server cache and it is remote. It is not on my computer. It is not on my hard disk. It's not anywhere near my LAN. So it is a remote cache. But it's generally called as a server cache because it's on the server and not on my local client system where my browser is running. Now, if you talk about an application which you are writing, so in that application, the word remote cache will have more sense, where you can either have a local cache, which is the same JVM in the same virtual machine or in the same code as your regular application code is running, whether it's C++ or Java or C. And a remote cache would be on a separate process, separate operating system process, which could be on the same box or on a different box. So both those. So that is the remote cache in that context. How do we make sure that cache becomes stale, and how we sync the data with real-time data? Okay, so Mutraj has asked that, and the answer again is not like a one-liner answer. It depends on your data and the rules around it. So if you have, for example, if you have decided to cache the company logo, then obviously you can put a longer expiry for it. And the only way that you can make sure that it does not become stale is that in case tomorrow your company decides to make a new logo, then you need to tell the cache that that one particular item has become stale, or the simplest way is to restart the complete cache so that it resets itself and it starts afresh and everything is requested again. Though that is not the most, the most quick way to do about it, and you are like making your cache simply request from all the items again, but it's an effective way. It's a quick and effective way. But the real way how we do it is that we, in our cache servers, we have a concept of clearing one item from it is requested again when a user requests it, and we also have a concept of for the resources like CSS and images, etc., where you can give a particular key pattern. So it's something like you say that all cache items where the hold on, I'm just trying to get a notepad up. So you say that let me try to increase the font. I don't know how to do it in that, so I can quickly do it here. Okay, so we have like a function where you can say, just like in a database, you would say like, delete where key like, and then we give a key like client1, and then you might have some functionality within that client like download and images. So all the keys which are like this will be deleted. So inside that keys like, for example, you could have 3 keys. Etc. And then all those 3 images will be removed from the cache and the fresh one would be taken. So that's the answer to how do we make sure that the cache data does not become stale. So you'll have to have some application level code to clear out the stale items from the cache. Or you should give a good enough expiry so that it automatically works. Do you have, okay, the next question by Jai Ganesh is, do you have any recommendations on how to avoid thread lock issues while reading hash map data from? So as far as I know, that most caches look after that for us, look after that automatically because it's a remote call, so the right logs will be maintained by the cache implementation itself, and we bother with that. But on the other hand, if you are using a local cache in your own JVM, then you need to make sure that you use a synchronized hash map. Or if you don't, you want to use a synchronized hash map, it must be at least volatile. And when you are writing to it, you must, I mean, you need to use a synchronized hash map is a simple answer. Or you have to have some, when you're writing to it, you need to notify other that this particular key is transient and it's not to be used for a few seconds. The answer is to keep a volatile and synchronized map. And I read is that in modern systems, I know all the Java books say that don't keep things volatile and don't keep things synchronized as much as you can. But that's the only way to go about it. Because if you try to make your own synchronization system when Java has a much better one, you will only lead up to frustration and it will not work. What is the difference in usage of cookie and cache for the remote server and the clients? Okay, so a cookie is just a placeholder on your browser, and a cache, again, depending on the context, is different things. That a browser has its cache, and cache in this webinar, what we are talking about is a cache in your Java application server side. If you're talking about web applications, it's on the server side, and that cache can be a remote cache or a local cache, and the cache can have any connection to a cookie is if your application code, for example, uses the value in the cookie as a key or as a value for a particular key. So that's the answer to what's the difference in usage of cookies. Then we have a question from Honey George. How do you fine-tune the cache or measure if the cache size is optimal for your uses, hits versus memory usage? Okay, so again, the of how one would fine-tune a cache, and what we have had success with is to make use of automated tools like JMeter, Selenium, running automated test cases, and then looking at how our caches behave. And of course, before that, you need to open an Excel sheet and you say that, okay, for example, if you're storing email templates, then you need to like write down in your spreadsheet, Excel or OpenOffice or whatever you have, that, okay, I have 10 clients and each of them can have 50 email templates, and each template can be 4 KB in size. So you multiply all this data, and you come up with some number, and then you divide it by 1024 to get big bytes or MB to 1024 again. And so that's how, like, if I had 50 email templates, how many small bytes cache would require, plus a little bit for the key, of course. So you can add the size of the keys also. So that's how you would fine-tune it, that you would say that, okay, the items which I can store, if I have, and how many items you will have at peak load. That is the important keyword, that at the peak of the application usage, how many will there be? And then you need to tell the cache that, okay, you need to keep, you need to run your tuning thread every 2 minutes, and you need to remove least read items, or you need to remove the biggest items first and then the least read items, things like that. There are the cache cleanup policies which you can tell the cache to follow. And there's again, it's more of experimentation and experience kind of answer, which will finally give you the thing. But the important thing to note is that if you are using your cache well, then even if you have not tuned your cache, nothing should really fail. It's just that your application might not scale up, and you should have other mechanisms like your web server limits, etc., so that your whole app server does not crash. And on the other hand, you might there are do is that we have like an initialization function which can be called at any time, so that like even in the night without restarting the server, we are able to tune the cache so that we see the performance for a few days, and if things are not going as expected, and if there is RAM, then we can increase RAM, or if the app server needs some more RAM and the cache server is not needed, then we can reduce the RAM from the cache server, things like that. Okay, so I think I've answered all the questions. I hope I have not missed any. There's a new question by Rohit. What is the optimal size for the cache for the Java Enterprise application? Well, there's an answer to that, because it all depends on what the application is doing and what the application code is trying to cache. So, for example, in the 3DS application which I was speaking about, we had cache from for each node. We used to have we had about 5 nodes which were running as cache servers, and each of them had 2 GB caches and of that. So and that was because we were storing the cache everything from Java objects, a few calculated values to templates, things like that. And we had sometimes we had like 80 TPS in a few times, and there's a lot of shopping going on. So again, it just depends on what your application is and what your business needs are and how much of resources you can spare, and then you need to open an Excel sheet and do this calculations, and then do some experiments, and then again do some calculations and tune it like that. And you don't need any fancy box. You can just do experiments first on your own local dev system, and then you can maybe move to a QA environment, a more formal QA environment. Okay. I'll wait for another minute if there are any more questions. Can cache be implemented with RAID technology? There are some disk implementations of cache, because finally a cache system can only use so much of RAM, and then there are some cache systems which, if they have enough security around them, then they can go back to the disk. And RAID is basically a way of making sure that your whole system is alive. So yeah, definitely you can implement, you can install a cache on a RAID platform. Answer is yes. Can cache purging be calibrated? Yes. That's another great question. And with custom code, you definitely can calibrate it so that at one point of time, you don't get rid of too many items, and you can maybe have like your custom background thread which goes through the cache and has listeners to the cache and knows what the keys are and how old they are, and in a very you can make your own algorithm. But most of the cache which I have, and what of the use I've seen is that we just give an expiry time, and we allow the cache to clean up on its own, and that works pretty well. So that's the answer for cache purging recalibrating. The answer again is yes, but I have not seen the need to do that myself. And another solution for calibrating maybe with newer JVMs where they're expecting that in the next 2-3 years we'll have JVMs where you have parallel GC carrying on, so you don't have to have GC pauses, then definitely that will become more important, and we should, I'm sure the cache implementers will have calibrated and a gradual kind of thing. Okay, so next, Umesh, is how local caches behave in cluster environment. Can we share the data among them? So the definition of a local cache is that it is local to the same JVM, but there is nothing stopping your application from exposing some interfaces like or an RMI or a plain socket or some other method where other application servers in the same cluster can ping it and ask for some particular data. But why you would do that, I don't know, because we already have easy remote caches. But if you are trying to say that it will be faster for local, and when another server wants it, then instead of recalculating it, it can ask it from one of the existing servers, then yeah, sure, you can make a custom interface which does that. And because that code also will be very similar to what the cache uses in general, you can leverage the existing code of the remote cache to implement that. But it will be a very custom implementation. But the simple answer is yes, that's very possible. And Rishi asked that, do we need a history maintenance for cache? All right, so the definition of a cache is something which just helps you speed up serving your your users, and it doesn't replace the actual origin of the data. So the application server or the database or the file system is the actual history. It's the actual place where you go for the truth. So the answer is no, that we don't need to miss for a cache, at least in all the use cases that I have come across. But again, a cache is just a piece of code which helps you do something. In this case, it helps you scale, and it helps in the user experience. So if there is some other business case which it's open source code and you could extend it, I guess, to make it. But the place you would do that would be in a database. Okay, I have 1 or 2 minutes more, then I need to get back. So last question, if there is any. All right, thank you all for attending. I hope you find the webinar useful. And again, you can go to the website and get the code. And after a week, by next Sunday, I'll be uploading some more information over here. Thank you. Bye-bye.
It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all.